Great. So Adèle Hénot-Mortier from MIT will talk to us about two kinds of adjective-infinitive constructions in acquisition.
Okay. Yep. So this is to move the slides, right? Okay, let me try. Okay, great. Thank you. Okay, yeah, so my talk is entitled Two Kinds of Adjective-Infinitive Constructions in Acquisition. And this is joint work with Rachel Stacey, Torma, and Athulya Aravind from the MIT Linguistics Language Acquisition Lab. Let me just start a timer. Okay, yeah. So let's start with a quick introduction. So certain subjective and event-modifying predicates like tough, impossible, or nice take infinitival clauses as a complement. Those predicates are called tough predicates and are involved in so-called tough constructions, which happen to be typologically unusual. Tough constructions are compatible with missing object or missing adjunct infinitives. So this is shown in respectively 1a and 1b, but they are not compatible with missing subject infinitives as shown in 1c. So we'll call the missing element in the infinitival clause the gap. So 1a, object of construction, Susie is tough for Joseph to talk to, grammatical. 1b, missing adjunct of construction, this car is tough to drive on this road with, again, grammatical. 1c, Joseph is tough to talk to Susie, is a subject gap, tough construction, which is ungrammatical. All right, so tough constructions, let alone their gap specificity, have been a long-standing puzzle in theoretical linguistics and theoretical syntax, more particularly. So two facts to note about those constructions. The first one is that they exhibit both A and A bar properties, which suggest that there are improper movement structures that are usually banned from the syntax. So this is very puzzling. Another fact is that they allow for an expletive variant, such as it's tough for Joseph to please Susie. And this also poses a bunch of problems regarding the theory of tetherable assignment. So they are very difficult constructions from a theoretical standpoint. And also, this might be the reason why they are notoriously late acquired, around 6 years old. And even at 6 years old, kids still mistake object gap tough constructions for subject gap structures. So to better understand the puzzle posed by those constructions, we want to compare their acquisition to that of another surface-similar infinitival construction, which will be less problematic from a theoretical standpoint. So syntax is full of other well-studied infinitival constructions involving gaps. So we have raising constructions, as shown in 2, control constructions, as shown in 3. So the acquisition of tough constructions has already been compared to that of raising constructions in a recent work by Ruth Brillman. But contrary to tough constructions, raising constructions are subject gap constructions, right? Not object gap constructions. And we think that this would be an unfair comparison to compare tough constructions with raising, because it has been shown in the past that subject gap dependencies are consistently easier to process than object gap dependencies. So yeah, this would be just a simple explanation for the reason why raising constructions and control constructions are just simpler to process than tough constructions. So we think a better candidate for a fair comparison between tough constructions and another infinitival construction would be what we call gap degree phrases. So what are gap degree phrases? Well, some gradable adjectives like fast, big, or hot can combine with infinitival clauses as soon as they are degree modified via 2 or enough. So the corresponding structure is called a gap degree phrase. We'll call them GDP. And so GDPs has been less studied in the past than raising or control constructions, but they seem to be more similar to tough constructions because they allow for an object gap. So this is shown in 4a. Lisa is too fast for Joseph to follow is an object gap degree phrase. Yet, unlike tough constructions, GDPs have no problems with a subject gap. So this is shown in 4b. Joseph is too slow to follow Lisa. So subject gap degree phrase. So in our study, we want to compare the acquisition of subject and object of constructions with that of gap degree phrases. And to do that, we'll use an elicited imitation task. So let's switch gears now to the study. So as I said, we want to compare tough constructions and gap degree phrases using also the gap parameter, so subject versus object gap. And so among the 4 constructions, only subject tough constructions happen to be ungrammatical from an adult point of view. So we want to explain where the difficulty of the acquisition in tough constructions come from. And so we have 3 potential hypotheses. The first one is the more general one and states that the difficulty with tough constructions is just due to general embedding problems and difficulty in embedding infinite clauses. Under this assumption, tough constructions should be just as difficult as gap degree phrases. Right. Then we have another hypothesis that is mildly specific and saying that the difficulty of tough constructions is maybe due to the fact that they are featuring an object gap dependency. Under that assumption, object gap tough constructions should be as difficult as object gap gap degree phrases and more difficult than subject gap degree phrases. Finally, we have a third possible hypothesis, which is the most specific one, saying that the difficulties of tough constructions are idiosyncratic and caused by special properties of those constructions. For instance, the fact that they are potentially improper movement structures, etc. Under that line of analysis, tough constructions should be more difficult than gap degree phrases across the board. So here is the study at a glance. So we tested English-speaking kids aged 4 to 7. We had 40 kids per age group initially. And as I said before, we used an elicited imitation paradigm that supposes that the ability to repeat a structure correlates with having acquired that structure. The study was around 30 minutes long, conducted on Zoom, and using animated slides, and also like various breaks and rewards to keep the kid engaged with the task. So here you can see a screenshot of one of those slides. It was a critical object tough construction trial. So you can see a big cat, that's mama cat, small cat, that's baby cat. Mama cat is telling baby cat a bedtime story, but at some point baby cat falls asleep, and that's at that very specific moment, mama cat utters the critical sentence, then exits the room, and baby cat wakes up. And once baby cat is awake again, the experimenter asks the kid to repeat this critical sentence that baby cat has missed. So a example script is given to the right of this slide. And yeah, the voices of mama cat and baby cat were pre-recorded, so it was an audio stimulus. So now some specifics of the study. So we had 2 groups, one group that was only exposed to subject gaps, another group only exposed to object gaps. We were starting with 4 training items of increasing difficulty, followed by 3 randomized blocks containing 3 constructions each. So 1 tough construction, 1 gap degree phrase, and 1 filler/control. And the blocks had various internal orderings. So let's talk a little bit about controls. So controls depended on the group. So dependent on the subject versus object gap group. The goal was to design the controls such that the proportion of adult grammatical trials was the same between the 2 groups. We wanted 2/3 of adult grammatical trials. So in the subject gap group, the control/filler was a grammatical structure with degree phrase and an overt gap, such as dog is too short for him to hug eagle. In the object gap group, it was an ungrammatical expletive degree phrase, such as it's too high for dog to hug eagle. And those controls were also used in the analysis as baselines for grammaticality or ungrammaticality. So let's go back to the predictions. So again, we are in this elicited imitation paradigm that supposes that the difficulty or ungrammaticality of a structure translates into a difficulty for the kid to repeat it. So the predictions of our 3 hypotheses become the following. So the first one, H1, was the most general, saying that TCs are problematic because they involve embedding. This predicts that the imitation rate of object of constructions, object gap degree phrases, and subject gap degree phrases should be roughly the same and slightly higher than that of ungrammatical subject of constructions. The second hypothesis, the mildly specific one, saying that it's an object gap dependency problem, predicts that object of constructions and object gap degree phrases should pattern in the same way, and should be more difficult than subject gap degree phrases and less difficult than subject of constructions. Finally, the last hypothesis, which was that TCs are difficult because they have idiosyncratic issues, predicts that the imitation rate of tough constructions should be lower than that of GDPs across the board, regardless of the gap. So let's switch to the results. So before doing the analysis, we had to perform a bunch of exclusions. So in order to be included in the study, the kid had to be able to repeat at least 3 out of 4 training sentences. The training trials could be repeated by the experimenter at most 3 times each. But so this filtering caused a bunch of problems for the 4-year-olds because they ended up having huge difficulties completing the task, and lots of them were actually excluded because of the failure in training. So we thought that keeping this age group for the main analysis would result in testing an unrepresentative sample of the 4-year-olds, namely those that are more like 5-year-olds. So we just ended up discarding this age group. Regarding 7-year-olds, they ended up being too good at the task, meaning basically they were just mimicking every structure they could hear, keeping them in their short-term memory, even the ungrammatical structures. So the data was not very informative, and that's why we eventually chose to just focus on the 5- and 6-year-olds. And this led us to analyze the data of 45 participants in total, 21 5-year-olds and 24 6-year-olds. All right. So to code the answers, we used a very straightforward binary coding. So 0 was for success, and we coded a sentence reply as 0 if the structure, including the gap position and the predicate class, was retained, meaning correctly repeated by the kid, modulo some minor vocabulary changes or superficial simplifications. And otherwise, we would code the sentence as a failure. So then we wanted to predict the error rate. And to do that, we used a cumulative linked mix model from R. So we had 3 main variables: age, 5 or 6, gap, subject or object, and construction, tough constructions or gap degree phrase. We also included 2 random intercepts, 1 for participant and 1 for trial. And then we tested different interactions. So we'll see that on the next slide, and selected the best model among all the ones we tested using the Akaike information criterion. So yeah, here are the different models we tested, so with various interactions between age, construction, and gap. And the model that was selected using the AIC was the model called the MACCG, which had 3 main variables: age, construction, and gap, but also 2 interactions: age and construction and gap, plus the 2 random intercepts. So let's look at this model. So this model was associated with various coefficients and p-values. So we had marginally significant main effects of gap and construction, because the p-values associated with those coefficients was just below 0.1, so yeah, marginally significant. The gap was associated with a positive coefficient, meaning that object gap constructions tend to be more difficult, in line with previous findings. Also, the construction variable was associated with a positive coefficient, meaning that GDPs tend to be more difficult, which is a bit surprising, and we'll see that the plots are not really in line with this modeling. Then regarding the interactions, we ended up finding 2 significant effects of the interaction. So the age construction interaction was associated with a negative coefficient, meaning that older kids perform better on gap degree phrases than younger kids, and older kids perform less well on TCs than younger kids. We'll see that in the plot very clearly. And regarding the construction gap interaction, it was associated with a positive coefficient, meaning that object gap degree phrases and subject of constructions are more difficult than subject gap degree phrases and object tough constructions. Yeah. So let's look first at the main effects. So here we have the effect of construction. We see globally on this plot that the imitation rates were globally high, above 80%. Yet we still have a clear contrast between the grammatical and ungrammatical controls in purple, right-hand side. So we have clear baselines for grammaticality. So overall, we notice that TCs in orange and GDPs in blue are close to the ungrammatical filler baseline. So we need to look at the interaction plots, the one that tease apart the subject and object gap for each construction to see what drives this result. But before doing that, let's just look at the main effect of gap. So here we notice that subject gap are slightly easier to process than object gap. This is in line again with previous findings on the fact that object gap dependencies are more difficult to process. And we also have to note that adult ungrammatical subject of constructions counted as subject gap structures in that plot. And that's why they might have undermined the global effect we see here. But so now let's look just at the interaction plots to clarify this. So here are the interaction plots. So I don't know if it's very readable, but from left to right is subject of construction, object of construction, subject gap degree phrase, and object gap degree phrase. And in purple to the right are the controls, baselines. So we see here that the imitation rates on tough constructions with both the subject and the object gap are indiscernible from those of ungrammatical controls. Also, we notice in the case of gap degree phrases, a contrast between the subject gap and the object gap case, because subject gap degree phrases pattern like grammatical controls, while object gap degree phrases pattern like ungrammatical controls. Right. So the pattern of GDPs, right, that we see here, so we have one bar, the first blue bar that is very high, second one that is low. This pattern is totally in line with the fact that object gap dependencies are more difficult than subject gap dependencies. Now, if we look at the pattern of tough constructions, we see that object of constructions are just as difficult as object gap degree phrases and subject TCs. So we see that, sorry. Yeah, first, second, and fourth line are approximately at the same level. And this is more in line with the second hypothesis, meaning the fact that tough constructions are difficult because of the presence of an object gap dependency. But now we want to try to confirm this conclusion by looking at the H by H plots. So here are the H by H plots. So 5-year-olds in pink, 6-year-olds in blue. Again, we start subject of construction, object of construction, subject gap degree phrase, and object gap degree phrase from left to right. So looking at this, we see that gap degree phrases follow the same general pattern across age groups, right? Because in both age groups, the subject gap degree phrase is easier to process than the object gap degree phrase, in line again with previous findings. But then for TC, something strange happens because we notice a drop in accuracy at age 6 for both subject gap and object gap tough constructions, right? So you can see in the first two pairs of bars, the blue bar is significantly lower than the pink bar. So it's a drop in accuracy in the repetition of tough constructions. So why is it the case? Well, the lower imitation rate in the case of subject of constructions might be due to the fact that children are known to learn about the ungrammaticality of those constructions around age 6. So this is consistent with previous finding that children learn that subjectices are ungrammatical at age 6. Then the lower imitation rate for object of constructions is maybe a bit less easy to understand, but it supports the fact that starting at age 6, kids start to have additional difficulties with tough constructions as opposed to gap degree phrases. So it suggests that the difficulty of tough constructions at age 6 is not only due to an object gap dependency, but rather also to special features of those constructions. So those results, this drop in accuracy, generally suggest that we have an emergence of special difficulties with the syntax of tough constructions starting at 6 years old. And this is more in line with the third hypothesis we had posited, meaning that tough constructions have idiosyncratic features that cause them to be more difficult. All right, so to conclude, in this study, we compared tough constructions and gap degree phrases, which are two surface-similar infinitival constructions, and we could confirm two facts. First, that object gap dependencies are generally more difficult to process than subject gap dependencies. And second, that kids start to get the syntactic difficulty, specific syntactic difficulty of tough constructions at age 6. And so as a conclusion, the difficulty of tough constructions seems to be caused by a mix of object gap issues in line with hypothesis 2, and also to a certain extent to special features of tough constructions in line with hypothesis 3, as suggested by the age-by-age data, and in particular the 6-year-old data. Thank you very much.
Okay, thank you, Adèle. Now we have plenty of time for questions. Okay, while people think of questions, I have one. So when you laid out your predictions, they made sense to me, but I did wonder why you were not predicting in any of those three possibilities an interaction at any point, or I'm not sure I understood that correctly, but so in other words, why were you not anticipating that the child data might just pattern a bit like the adult data and the adult grammaticality judgments? Was there a specific reason why that pattern was not expected, if it wasn't expected?
Sorry, so do you mean?
Yeah, so I think all your different predictions are about finding either a main effects or object versus subject, or a main effect of construction, or no difference between different types of constructions, but at no point you were predicting there would be an interaction between object subject and type of construction.
Yeah, I guess it was a bit hard for us to use interactions in the prediction because we had this particular case of subject-of constructions, which are ungrammatical for independent reasons. And so, I mean, they are like a bit out of the picture to some extent because they would be systematically judged to be very hard to process for kids. And so I guess, yeah, this is the reason why it was hard for us to set up clear predictions about the interaction between, let's say, construction and gap. And that we had this more like maybe convoluted hypothesis about not pairs, but triplets of constructions and so on. And yeah, I don't know exactly how to integrate the problem of subject-of constructions in that picture.
Yeah, that makes sense. Thank you.
Hi, I'm Björn Lundqvist. Thanks for this intriguing talk. I have a question about the relationship between the gap degree object clauses and tough constructions. Do you think those are different constructions? In the sense, do you believe that, say, the relationship between the surface position and the gap is different, or that the size of the infinitival clauses is somehow different, or are they actually the same clauses?
Yeah, that's a very interesting question, and I guess, I mean, there is no consensus about the reply, especially regarding tough constructions, because for gap degree phrases, it's pretty, it's pretty agreed that it's about a null operator dependency. So we have a null operator in the omitted clause that is bound by the matrix subject. In the case of the tough constructions, the picture is more complicated. So some people have argued that it's a movement dependency. So the matrix subject of the Toff construction originates in the embedded clause and then moves in several steps up to the matrix position. But then this poses the problem of improper movement and so on. So we have to accommodate for this. Another approach to Toff construction would be closer to that of Gap-de phrases, saying that it's a null operator downstairs that is bound by the matrix subject in the Toff. I mean, bound by the matrix subject. So it would be like the Gap-de phrase, but this poses other problems regarding federals, because under that model where we have the null operator downstairs and the matrix subject upstairs, basically what ends up happening is that the embedded predicate has to assign a federal to both the null operator downstairs and the matrix subject. In a way, we don't know exactly how, but it's very complicated. So both approaches to Toff constructions are imperfect. And I mean, I don't know, I don't know how like our study can answer to that question, because it was not the primary concern here. But yeah, I guess we should run another study to like get a better idea of what's happening with the Toff construction. But that's interesting.
Okay, thank you.
I'm Hiromu Sakai from Waseda University. Thank you for very interesting report of your study. Do you have any comment about the children's understanding of the meaning of these sentences? This might be a question about another study, but if you have any comment.
Yeah, here, so that's a very good point. In this study, we only focused on how the kids could repeat the sentence, but as we said, some kids may be mimicking, right? I mean, by this I mean repeating without understanding what they are like repeating. So one limit of the study is that we don't know what's going on in the kid's mind, and in particular, it has been shown in previous work back from the 60s by Carol Chomsky and other people, that sometimes object-of constructions are understood as subject-of constructions. And our design as it is couldn't test for this, because maybe kids repeat object-of constructions, but in their mind understand them as subject-of constructions. But again, I guess we should just change the paradigm and use something like, I don't know, a picture selection task, or yeah, another kind of semantic task to tease those two hypotheses apart.
Thank you very much.
Yeah.
Okay, we have got about 2 minutes left if anybody's got a quick question.
Hi, Federico Cavicchio from University of Salento. I'm wondering why, I'm just a curiosity, I'm wondering why you use a cumulative link model when you have a binomial distribution. Were you expecting some sort of ordinal effect in your 0-1? Because usually when you have 0-1, you do logic. That's why I'm asking.
Okay.
Just a curiosity.
I'm not an expert in statistics, so I guess it goes by the fact that we wanted to do an exploratory analysis after this main analysis based on non-binary coded data by having a more fine-grained topology, for instance, making a difference between failure at repeating, construction changing repetitions, construction simplifying repetitions. So I guess that's why I use the cumulative link mixed model here, just like planning for the exploratory analysis. But yeah, also I'm no expert in statistics, unfortunately. So yeah, that's what I did.
Okay, thank you very much. Let's thank the speaker again. Okay, and now I would like to call